a lathe tutorial. For this video, we're going to do the video version of the same tutorial that's in your manual and available online at our website and in the help file. If you want a fresh look at what the part looks like, we can go Help, Tutorial Parts, Lathe Tutorials, Lathe Geometry, and there's the part. Again, you'll find it in your main Powerstation manual. You'll find it available on our website. You can find the print from several different locations. One thing we should explain right from the outset is that we're going to show you kind of the longhand, or maybe you'd almost say the hard way of drawing up this part and machining this part. Learning the hard way will give you the ability to do virtually any job that ever comes in front of you, no matter how complex or simple it is. We'll show you the shortcuts when we get later on, which is a very short shortcut. So, where do we start? We're going to start defining our geometry, and we're going to start right up on the face of the part. You'll hear me turning pages here because I'm going to do the exact one. I'm going to follow it step by step by what's in the book so you can coordinate the two. From the menu, select Geometry, Line, Polar. So you'd say Geometry, Line, and Polar. Okay. Next, it's showing you this menu here. This is called the Get Point menu. And from it, select the origin. Alright, so we're starting at the origin. And how is our line going to go? Our line's going to be a distance of 0.5, which is the diameter, which is half the radius of the 1 inch diameter that we're going for. Now you can enter them in as diameter. Put in the diameter, divide 2. And for the angle, go 90 degrees. So we're going to go straight up from that origin, straight up a ½ inch. Okay, hard to see with the axes drawn over it. Let me get rid of the axes and refresh the screen. Not much to see, but anyhow. Again, let's select Geometry, Line, Polar, which you can also do from the toolbar here too. Lines, and Polar is this last guy over here. Polar. And we say, in this case, instead of saying from the origin, we're going to say from the end of the last line that we did. So we'll say end of and the line. And now the distance for this is we're going 1 inch and we're going 180 degrees. Again, this making that first turn diameter on the part. Okay. Here we have, next order is step 4 in the book, is display zoom in to make the geometry a bit easier. So let's say display zoom, and we can just bring it in a little closer. Alright, next we're going to select from the Geometry menu, Line, Tangent to 1. Geometry, Line, Tangent to 1. Okay. We want to start from that end point there, so we're going to have to, it says select a point or arc or escape for the point menu. So we're going to press escape, take the point menu and say take the end of this line. Okay. Now it wants to know the angle of the line that we're going to put in. We can put it in as either minus 30 degrees or plus 150 degrees. They're the same angle. So I'll say minus 30. I always like to use numbers straight off of the print if I can. And say OK. So now we drew that line. At number 5, we're going to say again, Geometry, Line, Polar. We're going to have this Get Point menu again here. In this case, we're going to start from some specific coordinates. We're starting at the back of the part, so minus 4.75, and the y is 1.5, or again, the 3-inch diameter divided by 2. Okay. Now it wants to know how far to extend that line. We gave it the starting point. The line now goes 3 inches at an angle of 0 degrees. Okay, so that made that outside diameter. And if we do a zoom extents, which again, display zoom extents or this icon on the toolbar. So now we're going to start cleaning this up a little bit. We can take from several locations. We can get the easy trim command we want. We can come over here to this toolbar and pick up this. This is the easy trim. We can come on this toolbar and look at trimming and find easy trim there. We can also go to modify trimming, easy trim. Same command, 3 different places to get it. One is no better than the other. It's what makes the most sense and is most convenient to you. So I like the toolbar up here, so I'm going to say grab me this easy trim. Okay. And if you look at the manual, it shows you the approximate points to select on this. You say I want to clean this area up. I'm going to say get rid of that thing and get rid of that hunk and get rid of that hunk of line. So now we're looking a little bit more like the part. We're done with the trimming command, so we need to press escape. Step 7, we're going to put a couple of fillet radiuses in the corners here. So let's see now. Again, the fillet command is one you can select from the 2 places in the geometry toolbar. It was one right here, or again in the modify trimming menu. So I'll take the fillet command from right here, and I'll select the entities to be filleted. Now with lines, it doesn't matter if you select this one first or this one first. It doesn't matter at all. If one of these were an arc, it is important to go in a counterclockwise area. So you would pick this one, then this one. So for the simple fillet, just click the 2 lines and give it the radius, which I believe was 0.25. Yes, 0.25. Enter. There's our fillet. I want to do the same command up here. Little note about that while we're here. You can press the insert key and the same command will repeat again, or you can click the right mouse button and say repeat the last command. A little quicker than going up to the toolbar, probably. Again, doesn't matter which way you use. Select these 2 lines. Radius is in there, still good. Hit it. You now have that area filleted. Okay, next one we're going to do is similar. We're going to add the chamfer to the front. This is the chamfer command. Again, it's available in the modify trimming menu or here. So I'll say chamfer, and same idea as the fillet. You select the first one, the second one, but now you fill in the exact. We have a 0.125 chamfer, and it's at 45 degrees. Alright, step 9 is save the file. Always a good idea. You never know what will happen from your power going out to some kind of a system fault or problem. It's best to keep saving and saving, as with any software. Save as lesson 2. Plain old lesson 2 sounds good. Okay, I mentioned before that there would be an easier way to create the geometry for this job. Let's take a quick look at that. Geometry, easy geometry, lathe geometry. I've cheated. I've already filled in the answers here just to save time in the demonstration here, but you can see I basically put in the dimensions off the print. It starts right here. It starts at the origin of 0, 0, and then it moves up to a 1-inch diameter. Insert a chamfer, a shoulder, move back 1.5 inches, a fillet radius, put the taper angle on it, then bring it out to the diameter of 3, put another fillet radius in it, and a shoulder in Z at minus 4.75. The number's right off the print. You can say show, gives you a little preview that it looks like what you want, and if you say at that point OK, it's just as if you had drawn it the other way. You can also take, once you've created geometry like this, you can say File, and you can save a file full of those commands to make that shape. It would really be nice if you had similar parts. You could just pull that file back up again, change the size of a couple of things, and have it draw the new part for you. So I'm just going to say OK. And now we have this geometry, which is just as good as the stuff I took all that time drawing. Okay, let's start the machining part of this video here. We're going to take, and we want to call up the operation menu, which, like everything here, has a few ways to get to it. You can say machining, and you can say the operations manager, or you can just choose this icon as the same thing. So I'll say operations manager. Okay. So now we start to build up our operations. This is basically where we're going to define our tools, our speeds, and our feeds. Let's start with an operation number. We'll just say operation 10. Let me give it a nice color of red for roughing. Sounds good. And we'll say rough turn. This column here, post, means whether you want that operation included in the NC code file that's generated. By default, the option to turn them on and off is disabled. So by default, you're going to get all of the operations, which is what people would normally want. All right, let's go to the details of that tool. We'll say it's operation 10. It's a turning operation. Tool number 1, offset 1. No fixture offset. We're on a lathe here. And let's 1/16, a nice 16th radius tool. Leave me 30,000 stock. And the lathe comp mode. This is what's called in many circles the lathe imaginary tool point that you have to deal with. Most show you a nice little chart of lathe tools on the rear or on the front, and basically you want to just set it to what you're doing. If you're doing any kind of normal turning or facing, we'll say OD turning. And IPM, no, we want IPR. And we'll just give it something, I don't know, 8 thousandths, and we'll do a little CSS of 500, and we got flood coolant on. Okay. Just to mention these other tabs in here, material and tooling are used when you want to take the tool that you want to use out of the library. You want to look it up in the library rather than enter the information like I just did. And the last one is the tool shape. If you want to use the solidify to see a solid model of this turning at the end, you'll want to put in the tool shape. It's not required at all. If you're not going to look at the solid model, you don't have to put this in at all. In this case, I'll do it just to show it's not really a big deal. I'm going to say it's a diamond turning tool. It's an 80-degree diamond. Relief is -5. Insert sticks out from the holder. I think it's about 1/4 inch. Been forever since I've done one. Tool radius, we already did that, but we'll just reinforce it at 1/16. It's a 6-inch, 1/2-inch inscribed circle. Okay, so I described the tool. Again, only necessary if you're going to run the solidify to look at it later. Has zero effect on the generated NC code. I'm going to finish up the other operations real quick, and I'll get back to you when they're done. Okay, we're back, and I filled in the other operations. 2 things to note on both the grooving and the threading. In the details here, you want to... Oh, I'm on the wrong line, sorry. I didn't look where I was. You go over to... I'll go to the grooving line here. I say details, and you'll notice the lathe comp is set to none, because in both grooving and threading, all the compensation is taken care of by the cycle itself, not so much by the system or by the postings part of the system. So anyhow, we get back to this, and let's start using them. Let's say, okay, I want to use I double click on that column. That turns that selects operation number 10. And the first thing I'm going to do is we want to put layers in there. Okay. Oh, and a home. Oh, good stuff. Forgot we had good stuff in here. Okay, step 12. We want to go back into the operation manager here, and we want to say operation, set the home point for all of them. Okay? So this is going to set what it considers the home position. On many modern machines, the home position is a relative thing. You really don't have to know. You always program it to 0, and whatever the machine's home is, it is. On some, you need to move back to a definite point. If you have one that needs to move back to a definite, so many inches in X and so much in Z, this is the place to put them in. I'm going to say it moves out to an X of about 6, but Z is only going to be about 2, a little bit closer to pull our tool changes a little bit closer there. 15, we talk about creating some layers. And layers are kind of a lengthy subject. To most new users, they seem kind of complicated, but they're really very simple. It's almost like having clear pieces of plastic, and you draw on one piece, kind of like when you did an overhead projector as a kid in school. You draw on one slide, you draw the part. On the next slide, you might draw the dimensions. On the next slide, you might draw a tool path. And then turning on or off a layer, each one of the slides is a layer, and turning it on or off a layer is whether you see it or not. So if you want to see all 3 of those things at once, you say, turn all those layers on. If you wanted to just you just want to see the geometry, you might have only layer 1 on. Let's do a little bit of that. Let's take and at least put our machining on a different layer. So what do we do in the example in the book? Okay, we put it on layer 100. Well, that's okay. Not quite sure why we had 100 in there. It really doesn't matter what number you use. So I'm just gonna keep it simple and say 1, and I'm going to call this machining. I can call this part. You don't have to name these layers. You don't even have to use them. If they bother you, if they're confusing you, don't use them. They're not important until you get down the line. You're starting to make more complex things. Then it helps you organize things better. That's all it does. It doesn't change what the system can do or how it'll do it. All right. So I just said name this layer 1. And make the current layer layer 1. Okay, so we're going to throw our machining on there. Okay, first thing we're going to do is we're going to use a facing cycle to cut it up, get it going. You can again address the facing cycle from machining, lathe cycles, lathe facing, or from the toolbar here, you could hit turning and select lathe facing from there. Both are the same. Okay, and we get the facing dialog. I'm going to say the largest diameter is 3.5, which is basically the OD of this part. No, let me go back on that. The OD of this part is 3 inches. Okay, so good. So that'll be the bar stock size. Smallest diameter, we want to face it right down to 0. Stock allowance, we want to leave 30 thousandths on it. The Z value of the face of the part is 0. Z value at the face of the stock, so that really defines how much stock is on the thing. Here's 0.25, which might be kind of a lot, but whatever you have, you have. Maximum depth of cut, and then the clearance amount, that's how far it's going to back rapid to or back off in between cuts. So that's it, and just say OK. And it did the facing cycle. It only took 1 cut. That's all it needed. Let's move on to roughing. We say we're in the lathe cycles here again, or machining lathe cycles, and take the roughing command. Okay. Depth of cut precise. Well, first of all, let's look over the top. We're roughing, we're doing external, and we're turning. Okay. So the depth of cut per side. In the exam book we have 1.25 1/8, that's fine. Per side stock allowance in X, I don't know, what do you like to leave? 10 in Z, we'll probably leave 30. Actually, we already put in 30,000 stock allowance in the operation, so I should do this the right way. We really only want to add to it whatever we want. I really only need about an extra thou on that guy, and about I'll do 10 thousandths on that one. Again, entirely up to you what you want. Clearance amount, that should generally be 0.1. That's how far you're staying off of it. The bar stock diameter, we said before we were going to use 3.5 inch stock. And the stock on the face of the bar, well, there's really nothing now. We clean that off with the facing command. Cutting right to left, assume the part origin is 0. Pretty self-explanatory numbers. Use can cycle if available. If a can cycle has been properly set up in your post-processor, with that option turned on, it'll use your can cycle. If you turn that off or it's not set up in that particular post-processor, you'll get longhand GO1, 2, and 3 and GOO blocks to complete the roughing. Let's say OK. All right. Now it wants us to select what we're going to rough. You notice we only drew just this part of the part. And part of the reason for that is when you're going to do the roughing, it says it in the book in several locations, but it seems to be the most common rule that people miss out on the beginning. Your best bet is if the tool's not going to touch it, don't select it. Don't select everything and say you figure out what part of it to cut. Select the parts that select what you're going to cut. So I'm just going to select, say, start here. Gives me a little arrow to show me which way it's going, and select the line or arc to stop before or escape for none. If I selected this line, then the roughing would stop right here at the end of this fillet. I want to select the whole thing, so I can just press escape. That selects the whole thing. Entities chained OK. Yeah, they look good. They're what I want. If you missed where you clicked just before, you could say no and go back and keep trying. Entities chained OK. Yes. The side to offset to. Okay, this is just which side of the part the tool is on. You really want to select it somewhere in the area of that first element that you selected here. So I'm going to say it right around here. Boom, it knew where to go, and it did the roughing cycle. Okay. And we've got some geometry, we got a lot of things in here. Let's save it again, just to be sure and be safe. Let's say save. SN2P, yes. Next, we're going to say go home. If you put in then this is optional because some machines will need it and some machines won't. Some it'll just be a simple code in the post processor that's always there for you. Some you actually put in a move to wrap it back to that position that we defined with the operation. So if you just say home, I'll go back. I saved it so I lost my current operation. Let's go back to the roughing here. Yes. And say just rapid move going home. Okay. So it shot home. We'll do the finish cutting. Again, we can go back to our operations, select the finish turn. Okay. And chain cut. Chain cut is kind of your workhorse command. All right, select the line or arc. If you wanted to start down here and do this little piece of the face, start it here. If you wanted to start on the chamfer and go back, start it here. All right. I'm gonna let it come up the face. May or may not want to do that, but your choice. And the same thing here. We'll press escape to stop to chain the whole thing. And they're chained OK. And the side to cut on is over here. And so, now what do? Let's get some of these in here. So we're doing turning. the cutting feed we've got here, clearance of 100,000 in each direction. The Z face, that we define the Z value of the face of the part so that if we indeed use this option which says retract the Z when done, it knows where to go for the face. Wrap it to the start position. Very good. Retract Z when done. Skip undercuts. If there are any undercuts during this kind of finish pass here, you may not want to go down into them, so you'd hit skip undercuts. What we could use here, let's include, I don't think this is in the book, but let's include putting on G4142, because that's something a lot of people need to do. Okay, you say G4142 cutter compensation. All right. You notice automatically custom approach and depart got checked, because you can't have cutter compensation without some kind of approach and depart. All right, let's go back to the cutter comp and see what it says. What do we got? Cutter compensation left or right or automatic. Automatic will work fine for us. And what compensation number? And it translates to, on most machines, what D number do you want that to come out in? All right, so let's say the approach now. This is a relatively simple approach for the lathe here. So let's just say we want a line coming in. Doesn't need to be a ½ inch long. Make it about 0.2 and let it come in there. I'm going to leave it at 45 degrees because I want to show you something with this. To be honest with you, sometimes exactly what angle to put and whether you need the absolute angle and whether you need to flip the approach side, sometimes it's not that obvious. So guess what I do? I guess, and then I take and look at the results. If it's wrong, I click on the reprocessing, I change the setting, boom, it's fixed. Sorry, I had wrong number there. Okay, so we'll do that for an approach, and we'll do something similar for a depart. We'll just start off that way. Let's do it. Okay, so actually my approach and depart look pretty good. Came in, gave. Now again, depending on what you might need, notice how that's coming down in X and down in Z. All right. We're going to make a note of it. In a little bit, we're going to get to showing you the job processing feature. And the job processing feature, we're going to change that so it's coming in kind of from the bottom right. In other words, moving larger in X and smaller in Z, which may be something you need sometimes. Maybe not. I don't know. Let's go back home again like we did before. And let's save again. Never hurts to save. Okay. Next thing we're going to do, the grooving is a pretty straightforward cycle when you're doing a simple groove like this. So let's take and select the proper operation. And let's take the lathe grooving command here. Okay, lathe grooving command does a lot of different things: straight grooves, contour grooves, or parting off. In this case, we're doing the most basic one, a straight groove on the diameter. We need to specify where that groove is. We're going to say the right side of the groove is at minus 1.16. The left side of the groove is at minus 1.25. The major diameter of the groove is 1 inch. The depth of the groove is 0.09. Keep wanting to double up on my decimal points today. 0.09. And the groove corner radius, that's the radius that on an OD groove will appear on the outside of it. In this case, what do we have in the example here? 5 thousandths, just a little break on the edge there. All right, the width of the tool we already know is 60 thousandths because this is just going to be a simple single plunge. 6. The tool corner radius. Most grooving tools, they, in my experience, have a small radius on their corner. This just helps this, actually the groove corner radius, it helps that be cut more accurately if you have the proper tool corner radius on here. For many jobs, it won't even necessarily matter. But I'll say there's 3,000th on the corner there. Clearance, 100,000th. Dwell time at the bottom. If you need any dwell time, put it in there. Well, what the heck? I'll just say 1. Or no, how about 0.5? Okay. And that's it. Good. Press OK. Okay. There we go. So there's our grooving. And let's save again. Let's do our threading. Thread. Oh. Okay. We'll select lathe threading from over here. All right. So now we start pulling through this one and find. Can cut that whole part out there, Barch. That was silly. Okay, now let's enter the proper information for the thread. What do we have? We have 12 threads per inch, and we have the total depth of the thread. Now you can use this button here to automatically calculate a 75% depth, or the most common depth. You can say calculate, and it pulls it in for you automatically. If you have some other depth you need, just put it in. Depth of the first pass, again, put in whatever's comfortable to you. Clearance amount, in-feed angle, can be 30, can be, I used to use 29.5 all the time. I like the little clearance in there. Output feed, thread diameter, the only actual diameter we're working with is 1. If you notice this second choice, select a line later, that's if you're making, generally if you're making a tapered thread, you draw the tapered line first, and then instead of giving it the diameter here, you just simply select that line later on in the process here. Z locations, where does it start in Z? It starts at 0, and where does it end? I got minus 0.955. What that basically was, that was me taking and calculating where the center of that groove would be. I basically took the number from the print. Where are we here? Which was 1.25. All right. But then I want to go back a little. I don't want it to go all the way to there. I want it to go a little less. So I'm going to say minus. And what do I want? Half the width of the tool. So I'm going to put in the tool, 0.06, and divide it by 2. So you can do math as you enter the numbers in here. I know you probably have a little desk calculator sitting there to do it with. Either one is great. The advantage to this is that it's done more accurately and it's done right on the screen here. You don't have to retype it in after you do it. All right, minus 1.28. Did I do that wrong? No, that doesn't look bad. We'll try that. And a left-handed thread. No, it's not. Can cycle options. Whole variety of things in here. Standard longhand G3233 type, which rarely used anymore because can cycles are really great for threading. But here are some of the other things you can do. You can pull out, this is a whole series of can cycles that we developed over the years that are already built in. You see a lot of different Fanics and Kumas and well-known controls in there. Or you can select the last one, says use the post threading macro. In other words, use whichever threading macro is a part of this post processor. One of the nice parts about that is that if your post doesn't have one defined, it doesn't hurt you because it just goes into a straight G3233 type mode when it makes them. But I'll say go ahead and use that post macro and say OK. Okay, so there was my thread put on here. Let me go in a little closer so you can kind of see more detail of what went on in here. Why didn't we see our cat? Because it was not a longhand G33 one. Let's go back and show how you fix that. One of the things about the specific can cycle options is that you don't actually get to see what you've done, because the can cycle is really an entity in the machine, not so much in here. Alright, let's zoom extents on the whole thing. I pressed the right mouse button and selected zoom extents. One of the big features of Powerstation is what we call the job processing. If you click on job processing, now we see kind of a history of everything we've done. We see the rough turning, and we did facing, roughing, and move and cut. We see what we did for the finish turning. See what we did for the groove, what we did for the thread. So let's work on both of the items I just mentioned. Let's go to lathe threading. And just so we can see it and confirm it's good, because you can always change it back again if you want before you post-process it, we'll say do the longhand one. Alright. And let's reprocess it just to see that. We don't normally you would probably make all of your changes first, but I like to make one change at a time and see what they did. So if I say reprocess, everything goes in, and there's my threading cycle I was looking for before. You can see it here. And if you look down at the infeed, you can see it coming in on the infeed angle. You can see the different depths of cuts as it got deeper and deeper, lighter and lighter cuts. Okay. Let's also take that chain cut command. I mentioned changing this approach right here. Okay. Let's go to the finish turn, chain cut, and instead of the sweep angle coming up there 45 degrees, what if we said it was at minus 45? I believe that should get us what we want. Let's try it. 45, okay. Notice another thing here. When I selected that chain cut, it showed me where I originally selected the chain cut. In other words, it reminded me of what item in the list on the job processing over here matches up with which part of the job itself. You can see the triangle shows me which line it was on. Same thing if I said the threading, or how about the rough turn. Let's say I took the rough turn here. I selected that one starting down there. But anyhow, I changed that infeed. I changed the threading, and I'll say reprocess again. Oh, didn't really do what I wanted to. Alright, let's try the infeed a different way. Let's say, go back to this chain cut. We have, oh, I did the depart at minus 45. I didn't want to do the depart. I wanted to do the approach. Okay, what I wanted to do was change the approach sweep angle to minus 45 degrees. Well, let's see how that works. And if I say reprocess, boom, now it's coming down. Let me scroll down a little bit. Now it's coming down and starting from that lower position. Again, whichever one you'd like. Okay, the next step would be generating the actual NC code. So now I've got something that, let me do a zoom extents to pull it all back in. Now I've got all my operations, all of my toolpaths in there. I can do, again, in several different locations, I can generate the NC code right here. I can get out of job processing and generate it here, or I can go to the machining menu and generate it in here. Post generate NC code. All three the same. Let's generate. Select your machine from the list. In this case, we'll just use D-lathe. Typical modern FANUC Haas type G-code lathe. Set the name for the NC code file. We're going to call it Lesson 2. Okay. And we're all set. We gave the name of the machine, we gave the name of the code file, we just say go. Alright, that generated the code. Normally you probably want to take a look at the code to make sure it looks like what you want. You can view it here, or you can finish with Powerstation and then load it into the Powerstation Windows desktop and look at the results, or load it into QuickLink and look at the results. Normally I just jump here, I say view the code, and it shows me the code in the results window up here. So here's what I got for this job. I got a roughing cycle. I got my finishing here, my grooving, and finally my longhand threading cycle, which if I had set it back to a can cycle, we'd see the can cycle there now. Okay, close, and we can close this guy up too. Let's do some dimensioning, just because dimensioning is fun, and I want to show off a new late addition to the system that's not in the printed tutorials. Let's add some dimensioning to this. Let's take the machining here. We'll make a new one we'll call dimensions, and we'll give it a default color. A nice kind of gray color is cool for dimensions. Let's make it the current layer. I double clicked on it, or you can change it here. And let's shut off the machining layer so we don't see all of that. Alright, good. So now we just see the part itself. Let's take and dimension it. First of all, let's turn on what we call Power Snap. I'm going to turn it on in two ways. This is the Power Snap button that turns it on and off. And one addition to the Power Snap is if you say the cursor mode, instead of asking you again and again, you want to get a point. What do you want? The end of a line, the midpoint of a line? And the Power Snap feature lets it actually figure out which one you want based on where you put the cursor. So let's take and do a couple of quick ones on dimensioning this. Drafting dimension. Let's do drafting dimension. Let's do a baseline dimension, and we're going to do horizontals. We're going to dimension some of the Z locations here. So let's take and do horizontal. All right. So I want to go from this guy. So here I'm saying the end or the intersection. See how it's highlighting what point how it jumps onto that point and then highlights it. So I'm going to say at that intersection. The next point will be the center of this fillet. And so here's my dimension. Let's do one like that. Okay. The next point I want is going to be the center of this guy. And the next point I want is the end of this point. You see how quickly it's letting me select those points to dimension it. We could do the same thing for the diameters. I think they might be a little better if they're done individually. I'm going to press Escape, get out of this command. Okay, well, that ends our little video here. I hope you've enjoyed it and I hope you found it helpful. Thank you.